Welcome to part 3 of transposing formulae. If you haven't watched part 1 and part 2, I would recommend you watch those two before you watch part 3. Okay, so first example we have change the subject of the formula to x. And the first example we have y is equal to x squared plus 5. Again, we need to get this x by itself, which therefore means I need to get rid of that square there. I also need to get rid of that 5. Again, we start by getting rid of what's furthest away from this x. So in this case, I need to get rid of the 5. It's a plus 5, so to get rid of a plus 5, I do the inverse operation, which is to minus 5 on both sides of the equation to keep it balanced. So I write y minus 5 equals to x squared plus 5 minus 5. And if you're really confident with what you're doing, you really don't have to write this step, because 5 minus 5 will give you 0. So now I have y minus 5 equals to x squared. Again, we agree 5 minus 5, that gives 0, so I do not need to write it. Now I need to get that x by itself, so I need to get rid of the square. So the inverse of square is finding the square root, which therefore means I need to find the square root of both sides of the equation. So I can write it like this, which therefore means that on my left I will just have the square root of y minus 5, and on my right, if I find the square root of x squared, therefore means I'll just simply get x. And remember, that was the aim, to get the x by itself. So that's my final answer for this question. Now let's look at a second example. Again, we need to make x the subject of the formula. So we need to get rid of this 2 here, we need to get rid of that square there, we need to get rid of that 1. We start by getting rid of the one that's furthest away, so it's a plus 1, which therefore means I need to do the inverse operation, which is the minus. So I minus 1 from both sides of the equation to keep it balanced. So I get y minus 1 equals to 2x squared plus 1 minus 1. Now I'm left with, on my left, y minus 1 equals to 2x squared. On my right, 1 minus 1, that gives me 0. I do not need to write it. Now my next step, I love this one. My next step now is basically to get rid of this 2 first before I get rid of this square. Okay? So how do I go about doing that? I divide both sides of the equation by 2. So I write divide by 2. I write divide by 2. Now I'm left with, on my left, y minus 1 all over 2, because everything is being divided by 2, equals to this 2 divided by this 2, that gives me 1. So I'm left with x squared. Very close, but still not there. I need to get this x by itself. So again, like in our previous example where we have that square, we need to do the opposite operation, which means that we need to find the square root. So we find the square root of both sides. I do that to indicate I'm finding the square root. So now I have y minus 1 all over 2, and this is taking the square root of all of that, and that's equal to, when I take the square root of x squared, I just simply get x. So my final answer for this is just the square root of y minus 1 all over 2 equals x. And this is what I wanted, x to be the subject. Let's look at our third example for this video. So we have y is equal to the square root of x plus 2. Again, our aim is to get this x by itself, so I need to get rid of that square root. I also need to get rid of that 2. Okay, so we start by getting rid of the square root, which therefore means that we need to do the inverse operation of taking the square root, which means that we square. So we square this side of the equation, and I also need to square my right hand side. So y squared just remains as y squared, and that equals to x plus 2. And remember, that's the aim anyway, because we have the square root of x plus 2. When we do the inverse operation, which is to square it, we just get what's under the root, which is x plus 2. My next step now is to get rid of that 2 here, which therefore means the inverse operation for plus would be minus. So I minus 2 from both sides. So y squared minus 2 equals to x plus 2 minus 2. Now I have y squared minus 2 is equal to x. 2 minus 2 gives me 0. That was my aim, to make x the subject. So this is my final answer. Now let's look at our final example for this video. We have y is equal to the square root of 2x, and then we have a plus 4. And again, we want to make x the subject of the formula. We start by getting rid of what's furthest away. So this 4, if you notice, is not under the square root, so we can first get rid of that 4. It's a plus 4, so to get rid of it, it therefore means we do the inverse operation, which is to minus 4. And we do that on both sides of the equation to keep it balanced. So I write y minus 4 is equal to the square root of 2x. And that's a plus 4 minus 4. Again, this gives 0. If you're really confident, you don't have to write it. So now I have y minus 4 is equal to the square root of 2x. Lovely. Again, we need to get rid of the square root. We also need to get rid of this 2. We first start by getting rid of the square root. So to do that, we need to do the inverse operation. The inverse of finding the square root is to square. So we square both sides of the equation. So I square all of this, and I square all of this. So now I have on my left y minus 4 all square is equal to, remember, when I do the inverse operation, all I get is just what's under the root, which is just 2x. And we're getting there. Now we need to get rid of this 2. And to get rid of this 2, it means that the 2 is being multiplied by the x. So I do the inverse operation, which is basically to divide. So I divide both sides of the equation by 2. And now I have on my left y minus 4 all square. I really don't need to simplify this because my aim anyway is to get the x by itself. And that's all over 2 because all of it is being divided by 2. And now on my right hand side, this 2 divided by 2, we agree that gives 1. So I'm just simply left with x. And that's it, because that's our aim. We wanted x to be the subject. We wanted to isolate x. Okay, so thanks for watching. Again, please remember to click that subscribe button, like and share this video.